Hi everybody, my name is Sergey Baidachny and I am a software engineer with 25 plus years experience in this area. And today I am going to start recording a session about how to build a drone. We will have more than one session. I'm going to split this video in probably several pieces, and we will start with tools and parts that we are going to apply in order to start assembling the drone. But prior to go deeply into our first topic, we need to answer a few questions. First of all, what kind of drone we are going to develop? And the second, why, and why I am recording these videos at all. So I will start with the latest question, why I am doing this. I am doing this primarily for students at University of British Columbia, because we are working at some projects, and this series is going to be a good background for them in order to understand the flavor of drone development topic. And later we are going to record some sessions about not just drone assembling, but drone programming. It can be very useful for our projects. But I decided to publish this series to the public audience because I strongly believe that it's a very hot topic now, and many of you probably are looking for content about how to start developing our own drones. The second question, what kind of drone and what kind of goals we are going to achieve in order to develop our drone? Because drone is a very broad topic. We can discuss submarines, we can discuss any kind of boats that we can manage from a ground station, for example, or we can even apply artificial intelligence in order to have autonomous boats. But in our case, we are going to concentrate at flying drones. It's still a very broad topic. For example, I have a flying drone like this. It costs almost nothing and it can fly indoor. It cannot fly outdoor. But we are not building this one. We need to build something bigger, and prior to discuss what exactly we are going to build, let's set some expectations at the end. First one, our drone should be powerful enough in order to have payload from 1 to 3 kilograms, for example. So it's pretty big drone, and potentially it can carry almost any camera. It can potentially carry any kind of elements that helps us to intercept, for example, other drones. And it's our first goal, build a drone that can carry payload from 1 to 3 kilograms. The second goal, we need some flexibility in management. We'll start building a drone that's called FPV. It's first person view drone that can be controlled by an operator using glasses, for example, any monitor, and operator can look at monitor and get information from drone's camera in order to make a decision there and how to fly. We need some flexibility in order to manage this drone. So we are not going to build, for example, fixed wing drone in this series because it's not easy to manage a plane. Moreover, we are going to achieve one more goal. Our drone should not be very expensive. Obviously, we can build something very expensive with super engine and with a range of usage for up to 1,000 kilometers, and manage from satellites, but nobody can do it at home. We need something that we can do at home. So that's why we will concentrate at a drone that has a price range from 500 to 700 Canadian dollars, and something that we can launch from almost anywhere. If we are talking about launching the drone from anywhere, we are talking probably about multi-rotors. So it's not fixed wing drone, but it's a drone that has several brushless motors, and this one, for example, it's a multi-rotor, it's quadcopter drone. It has 4 motors, but I have a bigger one, for example. This is a bigger one drone. This is 7-inch quadcopter. It's pretty close to that one that we are going to build. We are going to build a little bit bigger, but it's still going to be multi-rotor and quadcopter drone in order to make sure that it's flexible from navigation perspective, it can carry good enough payload, and it can have a range up to 10 kilometers if you're talking about round trip, and probably 20 kilometers up to 20 kilometers if you're talking about one-way trip. For some tasks, potentially your drone will fly just in one direction only, and you'll never see it again. So it depends. But I found that drone that can potentially satisfy our requirements here, be cheap, long range, fast enough, probably 100, 150 kilometers per hour, and not very expensive. It can be a 10-inch quadcopter. And quadcopter means that it should have 4 motors. And in fact, it's probably the biggest drone that we can build for $500-700. Everything that is going to be bigger, 13, 15-inch copter, what does it mean 10-inch, for example, or 7-inch, this is 7-inch drone. 7-inch means that from the center of the drone to end of any arm, it's exactly 7 inches. In our case, we will have 10 inches from the center to the end of the arm. But everything that is more than 10 inches is going to be more expensive because you will need to use more expensive frames, you will need to use more expensive motors, and they should be much bigger propellers, and probably better electronics, etc. But if we are talking about that range that I mentioned before, 10-inch drone is exactly what we need, because in this case, you can see, for example, we're using a frame that just cut it from a sheet of carbon, and it's not very expensive. And this frame, for example, costs about 25-30 Canadian dollars. But if you're talking about a frame that 13, 15-inch frame, it usually uses carbon tubes, and there is different cost for such a frame, starting from 150 and good frame from $300 for frame only. So that's why let's concentrate our attention at 10-inch drone. And once you understand all the components, and once you understand how to build such a drone and how to set up it, you'll be able to go ahead and build almost anything. So let's go into my lab and let's start discussing about what kind of tools and what kind of parts we're going to use in order to build this drone. I'm going to briefly discuss all these questions right now, and later, once we start developing the drone step by step, I will probably spend a little bit more time at every component that we are going to use. Why I bought exactly this component or that component, what kind of options we have, what kind of parameters each component has, and so on. And one important intention for the end of the course, we will need a platform that later will be able to program as well. So that's why we'll pick some components from this perspective as well, to make sure that we have a platform that we can use in order to install some probably open source software and start developing software for our drone, not just hardware. But it's another question, it's a topic for another series of videos. Let's go into my lab. Okay, let's start with components that we need to buy in order to assemble our drone. I will start with the frame. In our case, I am going to use Mark IV V2 frame. It's not original version, it's a clone. You can find lots of different stores on AliExpress to buy this frame for 35, 40 Canadian dollars. It's most common frame for 10-inch drone, and it has almost everything that you need in order to assemble it, including even a strap in order to fix your battery. So all bolts, everything is inside. The only thing that it does not have, it's an instruction. I did not see any frame that has an instruction inside, so we will definitely record a video about how to assemble this frame. The second thing that is very important, it's a flight controller. Flight controller, it's a brain of your drone, and there are various kind of flight controllers. We are going to use a flight controller from Matek SIS, and it's called H743 Slim version 3. So it's something that we are planning to use. The reason to use exactly this flight controller, we have two reasons. First of all, it uses a pretty good microcontroller as a brain for it, and compared to F7 and F4 microcontrollers from ST Microelectronics, it's a much more advanced one. The second important thing, this flight controller supports different kind of software. There are several open source platforms for drones that usually you can find. The most popular for people who are doing racing, Betafly. But in our case, we are going to use ArduPilot. And if you look at ArduPilot website and supported hardware, you would be able to see many cheap flight controllers. But this one, it's not cheap compared to F4 flight controllers, but it costs about 100 Canadian dollars, but it's officially support ArduPilot, and you can install ArduPilot onto this controller. What is ArduPilot? We will discuss it later, but you can install it here, and you can potentially add all components that ArduPilot supports, and even a companion computer, and program your drone using C programming language, for example. So it's the second thing. In order to, of course, operate our drone, in order to make sure that our drone is flying, we need motors. We will need 4 motors. I prefer motors from company called T-Motor. They have a website. There you can buy these motors, and in our case, for 10-inch drone, we are going to use motors that called V3115 900 kV. kV means number of rotations per volt, but it's not something that we need to know right now. We will discuss all this stuff later. Just remember what kind of motors we need to buy. In fact, on the market there are many very similar motors from different companies, Brother Hobby, JPRC, but this one, it costs usually 2 times more rather than any other analog, but it's very reliable and probably the most powerful motor in this range. We have to mention that each motor should have a propeller. Usually you can buy propellers in pairs, because they're different. They can be clockwise and counterclockwise propeller, and each usually pack contains 2 of them, CW and CCW. And in our case, we are going to use propellers from T-Motor with parameters 9.5 by 5 by 3.
What is this? We will discuss later once we start assembling the drone. But I would recommend exactly these propellers for some reasons. If you can potentially buy something else, but there is a risk that you can overload your controller, and it's a topic for next probably session, but as for now I'm going to use this one. So motors, propellers, some important things: bolts. Usually you can find bolts in your drone frame kit. There are lots of them, but it does not have bolts in order to fix motors. You can find some bolts in a bag with your motors as well. So you can see lots of bolts. None of them will satisfy our needs. They are not long enough. I don't know why T-Motor is doing this, since this frame, in fact, is not very expensive. It's one of the cheapest frame. Usually more expensive frames can use thicker carbon, and you need even longer bolts. But we are placing bolts, I believe 7 and 8 millimeters long, and we will need M310 bolts in order to fix our motors, and it's something that you cannot find in your kit. So that's why I ordered many of these bags on AliExpress. It cost almost nothing, but it requires some time in order to get your package. You can buy on Amazon kit like this. Of course, it's more expensive, and usually you don't need to use all these bolts at all. But you can see, if you look inside, I don't have exactly M3 by 10 bolts. So in this case, you can see that I am using probably very often compared to all other components here, all bolts and nuts from this box. One more thing that can be useful, since we are talking about bolts, we probably need to buy plastic nuts. You can see various kind of nuts, and usually we're using this one. So it's the basic one, but it's not metal, it's plastic, because metal in some cases can generate a shortcut for your flight controller. So not every flight controller contains enough plastic nuts, and in our case we'll have lack of them. So I would recommend to buy enough plastic nuts for M3 bolts, and I have it here. And let's go next. So we already discussed frame, we already discussed motors, and we already discussed flight controller. Next component is going to be a board to control motors, because these motors using AC current, and our battery going to produce DC. So we need, first of all, a board that will convert DC to AC. First of all, the second, a board that will control how much power to send to any motor, and it can be managed, of course, by a flight controller in general. So we are going to use 4-in-1 motor controller. You can see that it has enough contacts, and each motor has 3 wires, so it has enough contacts to attach exactly 4 motors, and it has 2 contacts in order to attach a power cable and connect it to a battery. So in our case, we are going to use a controller from a company Holybro. It's called Tekko F4. That Tekko 32 F4 metal, and pay attention that it should be marked as M32. This controller can hold up to 65 amperes per motor, and even survive if you send 75 amperes to a motor for a few seconds. And this motor with that propeller that I demonstrated to you requires up to 70 amperes, so it's good enough for a controller. Obviously we could buy something better, but better usually much more expensive. So this one is the best if we're trying to compare capacity and if we're trying to compare price of this motor controller. And it's the second thing. So in general, motor controller is something that we are going to attach to our flight controller, and flight controller is going to send information to this board about how much power should be transferred to a motor, to all of them obviously, and depends on how you're going to manage your drone, if you're going to fly up or forward or down and to end. It can send different amount of power, and thanks to that your drone will fly using 6 degrees of freedom. And next thing that we need to buy for this stuff, I mentioned that we will need to connect a battery to this one. And usually, at least even cheaper motor controllers have a cable with a connector. In this case it has nothing. So it means that we will need to find a way how to build our own connector to a battery. And in order to do this, we will need to buy wires. So I have this one. We have parameters AWG 18. Sorry, not 18, 12. 12, and pay attention that it should have mark on that it's up to 600 volts and up to 200 degrees by Celsius, because on Amazon you can find lots of different wires with different parameters. In our case, once again, it's going to be 12 AWG. We'll just cut a small piece of this wire and connect to our motor controller board. But in order to do this, we will need a connector as well to make sure that we can attach a battery. We will need a connector, XT60 connector. There are many of them on Amazon. They cost almost nothing. So we will need to solder a cable to any of this connector, not to any, but to exactly that one that you can fit your battery, because there is male female. And after that we can go ahead. Since we have frame and we have motors has wires, and they are located, as we mentioned before, it's about 10" from the motor controller board. So it means that your wires will vibrate, and you need to find a way how to fix them. And not just wires from motors, you will have many different kinds of wires that you will need to fix. So different kind of ties are very important to buy in advance as well. So it's more a component that we are using for every drone. I prefer to have 4" tie. It's like the most common one. Next common one, 6, I believe, inch, 6 inch, 15 centimeters ties. I prefer black color, obviously, and our drone is black, and white color is not the best one, but I didn't find black. I just found that I don't have enough, and I did not find black in the right size. In Home Depot, usually you can buy thousands of them in big bags, and if you are planning to assemble more than one drone, it's something that I would recommend. Buy a big bag of ties, 4 and 6 inches, and you will be able to see that you spent almost all of them in a few months. So next component, a capacitor. This board requires a capacitor in order to guarantee that current is stable and there is no any kind of interruptions, and your drone will not fall just because you have some sort of interruption in your current supply or anything like this, like even short one. Usually every motor controller board has a capacitor. In our case we need 35 volts and 1000 microfarads. But this capacitor is not good one. This kind of capacitor you can find everywhere, but don't use it. It's not enough. Usually it's small and it does not support a drone. Then you are going to fly fast. You can find that your capacitor just does not work anymore, and it's dead because one or both legs suddenly has been broken, and the capacitor itself does not operate properly. So it's like very cheap capacitor that I don't recommend to use. Usually I'm putting them into a garbage bin. I would recommend to buy capacitors from Panasonic that have a little bit better quality, and there are different kind of them. It's like even not the biggest one, probably smallest one, but even you can compare that even this smallest one in 2 times bigger than this cheap made in China capacitor. So Panasonic one with the same parameters, 35 volts and 1000 microfarads. It's something that you need to buy on Amazon. Usually they are even a little bit bigger in order to make sure that you have stable power to your motors, and one capacitor per drone is good enough, at least for 10-inch drone. If you're building more than 10-inch drone, usually you're putting additional capacitors per motor, and even one capacitor per, I don't know, 5-10 inches of your wire, if you have really long wire, can be placed for bigger and more expensive drones. But it's something that we don't care much. We are going to use just one of them. So capacitor, what next? Obviously, in order to see how to manage our drone, to see where our drone is flying, and be like an operator of the drone, we need a camera. 2 companies that produce the most famous cameras. First one, Foxeer, the second company, Caddx. Usually I prefer Caddx Ratel Pro camera that you can buy on caddxfpv.com website. In my case, I don't have Caddx today, I have Foxeer. Always a Foxeer with infra red light, so potentially it can produce better quality during sunset, but during daytime it can produce a little bit different colors. Usually if you have, for example, green color, it can show a violet or anything like this, because it's just recommended for primary time, then you don't have much light. It's not like zero light camera. You still need to have enough light to have a good picture from it, and it can be used during the daytime as well. But in this case, once again, you will have a little bit different color schema here, but it's enough for us. So the camera is almost the same, and if you're talking about how to connect this camera to the drone, like the schema is going to be the same for all of them. But if you have a chance to buy Caddx Ratel Pro, let's do this. Usually it's a good camera that I would recommend for 10-inch, 7-inch drones as well. For Xera as well, especially if you're going to use a camera that should survive during like rainy weather, for example. They have many different options, and we have daylight cameras as well, not just with infrared light, and we have the same version that works fine during the daytime as well. But this one, called Foxeer Nightcat 3 Mini, it just does not work during daytime by design, but good enough for us. So I'm going to use this one, and usually you have all needed bolts with your camera. And from management perspective, how we are going to operate our drone, we need two things. Camera is not enough to send a video signal for our monitor. We need a video transmitter. In this case, I'm going to use a video transmitter from company GPRC. It's going to be a video transmitter called Matek 2.5 watt VTX Pro. So it's a very good video transmitter, very powerful, and if you're talking about range, long range, it can satisfy our needs, and it works on 5.8 gigahertz frequency. So this video transmitter has almost everything rather than an antenna. Antenna is the second thing that we need to buy in order to send video to our monitor. In this case, I'm going to use GPRC antenna for this stuff. Pay attention that since we're building a long range drone, antenna probably is going to be not very short. I bought 17 centimeters antenna. It's antenna for 5.8 gigahertz as well, because they have different frequencies, frankly speaking, so pay attention that it should match your video transmitter, and pay attention that it has a mark on that called RHCP. Usually you can pick between R, right, HCP, and L, left, HCP. Building multicopters, we always using RHCP. So it's very important, pay attention to it. And in fact, you can buy this antenna, it's called GPRC Mamoda 2, 5.8 gigahertz, RHCP, SMA, antenna 17 centimeters. SMA means it has a connector like this. Let me show it. Connector like this, and you can see it's a male connector. Usually, if you have a video transmitter, you can find a PigTail, and in case of GPRC, you can find it here. You can see that it's female, so it can match to each other, and we can connect this PigTail to our VTX like this and connect it to antenna. But I prefer to have, you can see this PigTail has an angle. I prefer to have straight PigTails with no angle, so probably because it's easy to, we will need to have a 3D print at the end, and it's easy to match our 3D print in order to make sure that it will not fall out and we have stable connection. So I don't like angle connections here. So usually I'm buying PigTails on AliExpress and use them. But even for this build, probably we'll use this standard PigTail in order to reduce number of components that you need to buy. So VTX, and VTX allows us to transmit video to our monitor or glasses or whatever what we are using in order to see image from the drone. But we need one more component in order to control our drone, receiver. Receiver that will get commands from our controller and will help send these commands to our flight controller, and flight controller will obviously operate our drone based on these commands. So this receiver, we are going to use a receiver that is based on ExpressLRS technology, and this receiver is the same from GPRC companies. I was not able to buy everything on the same website, so I tried to at least reduce number of websites. So you can see GPRC, at least we have 3 components: VTX, we have antenna, we have receiver. So this one is a good one. It supports ExpressLRS, we'll discuss it a little bit later, and this receiver supports 2 different frequencies, 9, 15 MHz and 2.4 GHz. Usually for long-range drones they're using 915, and it's something that allowed in North America. You can use it, and you can, especially if you have transmitter, you can reach range up to 20 kilometers, so it's possible using this frequency. 2.4, it's a common thing that all consumer drones are using, but obviously it's not so big range in this case. But this particular receiver can get commands using both bands at the same time. That's why it's called CrossBand receiver, Gemini. I will discuss it a little bit later, but this one, it has 2 antennas. One antenna works on one frequency, another works on the second frequency. So potentially you can set up it in a way that both antennas will use, as for example, 915. It's not important as for now. You can buy almost any ExpressLRS receiver. My recommendation, buy this one. I used it for many drones. It works pretty well. So what else? I believe that's all. We discussed almost everything. So once again, frame. On our frame we are going to install our flight controller. We are going to install a controller for motors. We are going to attach obviously 4 motors to it. We are going to add a camera. We are going to add a receiver to get commands. We are going to attach a video transmitter in order to send video to our monitor, and the antenna. And some additional components, as I mentioned, capacitors, ties, and different kind of bolts, wires, and XT60 connectors. So it's all what we need as a set of components. You can see it's like pretty big chunk of everything. Potentially you can ask, what about GPS, for example? We are not going to use GPS as for now, because for many tasks we cannot rely on GPS. We assuming that we are going to work in GPS denied environment, but if you would like to attach GPS, nobody can stop you. One more thing that I did not mention, in order to fix, for example, antenna for the video transmitter, and in order to fix camera or in order to fix antennas for ExpressLRS receiver, you will need some 3D prints. These frames usually you can buy with no 3D prints. If you can see a frame with 3D prints and see that it's more expensive, don't buy, because usually those 3D prints that they have in the kit, they don't help much, and you still need to print own 3D prints. From time to time, especially if you're buying Caddx Ratel Pro camera, you will be able to use carbon plates in order to fix your camera directly from the kit, but you still need 3D prints for your VTX and for your ExpressLRS antennas. So that's all what we need to use in order to build a drone from components perspective. Now we need some tools as well, and you can see that I have many things had at least right now. It should be clean, but I have had many things on the table, and usually I have a bucket next to me, and once I finish any drone, usually I have a bucket of garbage, because all these boxes are going to go into the garbage, and it's just to build a single drone. Yeah, so you should be ready that you're going to buy many different things. But once again, price range $500-$700. So yes, much, but it's something that you have to expect. Now we are going to discuss tools and why I divided tools and components to assemble the drone itself. Because in the case of tools, you're using the same set of tools again and again, especially if you're going to build more than one drone. Yeah, so it's wisely to buy a good set of tools, and after that go ahead and assemble all your drones with no issues. So let's go ahead. Tools. First of all, we need to have obviously a soldering iron. In my case, I have a soldering iron station from Hakko. I don't remember which model. Hakko FX888D. It's really hard to find it. I believe it's made in Japan, but it works pretty well for several years. And you can buy any station, in fact, but make sure that your soldering iron has different kind of tips, and you can change tips as much as you need. Usually you need at least 3 sizes, and let me explain how to pick the right one. So let's look at motor controller once again. Motor controller, this one. You can see that we have several different plates for power cables. In order to make sure that your power cable, you can solder your power cable to the board, you need big enough tip, and usually you can see that at least one dimension of this plate is equal to dimension of the tip itself. It should not be bigger, because in this case you can damage other components or you can overheat the board, but it should the same height by at least one of the dimension. The second dimension is a little bit bigger, but it's okay. It's okay. If I'm going to use this tip, for example, I will never be able to solder a power cable with a good quality. I will need to probably do it step by step, and it will generate lots of bulbs around the cable, and it will not connect to the board. But I'm using this tip, next one, in order to connect motors to these plates. You can see that height of this tip is equal to height of the plates for the motor, and it works good enough. From another perspective, if you're talking about flight controller, let's use another drone. I have another one, and there is speedy beep flight controller, but for Matek they have the same. You can see plates for smaller cables don't look too big. Yeah, so you need obviously different tip for that stuff, because if I'm using, imagine this one, yeah, what I will be able to solder? Nothing, yeah, so I can just damage my board. Obviously, if you don't have soldering experience, don't solder anything right away. It's easy to find some kits that can help you to practice your skills first, and after that use expensive fire controller, because you can buy a kit for $10, for example. Fire controller costs $100. Motor controller costs $100 as well. But first tool, as I mentioned, soldering iron with detached tips. Obviously, in order to solder, you need some additional components. First of all, you need solder itself. This one, for example, it's almost done. I had one more somewhere, but usually it's 60. So if you're talking about parameters, SN should be about 60 and PB it should be about 40. And it can have some components inside that help you to solder better. So for example, you can see it has flux inside for about 2%, and flux is the second thing that we need to apply to our elements that we are going to solder, in order to make sure that our solder cover everything well and does not generate bulbs, but cover the wire and plate that they're using to attach the wire as the whole thing and cannot be detached. But even despite on the fact that many different kind of companies produce solder with flux, we still need to buy flux paste usually that will apply during the soldering process. You can see that in my case I'm using flux from MG Chemicals, and it's called no clean flux paste. What does mean no clean? In some cases you can apply flux, but it must be cleaned, or it can potentially damage your electronic components in time. This one should not be officially cleaned, but I always recommend to clean your electronic components after you finish soldering. In order to clean, you need to use a toothbrush and isopropyl alcohol. It's something that you can buy in any drugstore and it costs nothing, but it's a very useful thing in order to clean your electronic components and remove not needed flux. Because yes, if you have too much flux, potentially it can affect your power supply, it can affect your power circuits, and potentially it even create a shortcut. So don't leave much flux on your electronic component. Soldering different kind of components, if you make a mistake, potentially you would like to remove some solder, and this, how it's called, good wick, I don't know, but it's some sort of copper, not wire, but I don't know, net, that you can just attach to a place they would like to remove the solder, apply heat, and it will get all the solders. So you will be able to desolder or just remove not needed solder from your electronic component. It helps you to remove some mistakes. And if your soldering station don't have this sponge, you need to buy it as well, because you need to clean your tips, soldering tips, every time then you're doing new operation, and it's very important. In my station I have this stuff, but I still have it separately, because for me it's easy to put it here rather than move my soldering iron too far to the soldering station. I have a cable, yeah, long enough, and everything should be placed in an area they can each reach it with no issues. So we discussed soldering related things that we need to have. One more thing, we need to use wire cutter in order to cut our wires, because even in this case we are long enough with 10-inch long, we will need to cut them, and we are not going to create any loops or anything like this. So this stuff is very important. You can see in my case it's like really dirty and it's old, because I'm using it on daily basis and cutting many wires. And prior to start recording this video, I spent probably a day in order to clean my desk, because it was lots of wires and different kind of garbage here. So it's very important. One important thing that you can see on the screen all the time, this silicone carpet. You need it. You need it if you're not going to kill your table after the first run, because it's really hard to clean the table, but this stuff can be cleaned very well. It was really dirty with lots of wax solder on it, like even yesterday, yeah, but now I cleaned it and it looks like new. Not new, I probably could apply additional effort to clean it, but it's in a good shape. And you can see it's magnetic one, in fact, but I can solder on it. I can put some bolts, nuts here, and they will not just travel in their own direction. They will just sit here. That is very important. So silicone carpet is one more tool. One more tool for soldering. Usually you can buy different kind of helpers. Yeah, so if you need to just fix some components and solder them, these tools can be very useful. I bought it many years ago. Now I found on Amazon you have like different kind of new versions with flexible wires, etc. So, and they don't cost much. So buy the most favorite one. But I have this one. It's old, but it's something that I have here. So one more important thing. What else? Glasses. Protective glasses. In my case, I have just regular glasses, because I need glasses to see stuff. They work as well, but if you are not wearing any glasses, buy protective glasses, because you can just, you know, especially if you don't have soldering experience, solder suddenly can go into your eye and it can be damaged. You can see that I have one eye damaged, but it's not due to soldering, it's due to fishing. It's another story. So that's why usually I care about security and just like safety, etc. Multimeter. I bought something, the most cheapest one on Amazon. You can buy any of them. From time to time it can be a useful tool as well. So multimeter, it's like one more tool that I always have in an area. Something basic, even wipes, wet wipes, in order to clean like things around, and very important. Yeah, I'm using many of them. Yes, cost nothing, but if you don't have any suddenly, if you start soldering and assembling your drone and you don't have any, it's a problem what you have to do. Next, usually I'm buying lots of heat shrink tubes, different diameter, I believe starting from 1 by 4 inches, even 1 by 4, 1 by 2 inches, and so on. They can be very useful in some cases. So depends on what kind of drone you're going to develop. In our case, we need something with like probably the smallest diameter that you can find. For example, we have this capacitor. We probably would like to put legs of this capacitor inside this heatsink tube, just in case, to guarantee that nothing will force our legs to connect to each other and generate a shortcut. Obviously, we'll try to cut our legs as much as possible, but it's not always possible in some designs. So that's why it can be very useful. For bigger drones, then you have not a universal 4-in-1 motor control board, but you have a motor control board per motor, and it's usually called, yeah, I forgot to mention, it's usually called ESC. You are using much of this stuff because you have much more wires and you need to find a way how to connect. Once again, XT60 connectors. You can see in my case, we have these tubes in the kit, because once you solder the wires to these spots, you probably would like to make it add some beauty, and you would apply shrink tubes to make sure that there is no metal that exposed to the air, to probably, especially if you have rainy weather, to rain and so on. In some cases you're using not tubes, you're using a special plastic adapters to cover all your soldering points from the environment. So done. And what else? Let me see what I have on my table. This stuff is Threadlocker. Threadlocker, that is blue. Trust me, it's going to be blue. I don't know why we are selling it in red bottles, because why it's very important, because usually we have two kinds of Threadlockers, red one and blue one. They help us to fix some metal bolts. For example, you can attach motors and apply this Threadlocker to make sure that your motor will not just disassemble during your flight from the frame. If you use red one, it's really hard to disassemble after that. If you apply red one, especially having in mind that all these bolts like made from really soft metal, red one, you probably will damage your bolts and will not be able to disassemble your motor. At least you will need to use some tools in order to cut them out. But if you're using blue one usually it's not so strong and it's good enough, but from the second time you can, from another point of view, you can disassemble your motor with no issues. Okay. Next important stuff, especially if you are planning to fly during the rainy weather, it's a silicone coating for your electronic components. So once you finish your assembly, you can apply this coating and cover all your electronic components using it, and it means that if water will just go down, not just water, it can be grass, it can be moss that is probably wet, to your board, it will not generate any shortcut. Usually I'm applying this stuff just in case, if I know that I'm not going to disassemble the drone and attach something else, etc. Or if I know that I'm going to apply in the rainy weather, during the rainy weather. This stuff, you still can solder components on top of that. So you can use isopropyl glue to remove it. You can solder directly on top of this silicone, and your soldering iron will just remove it automatically, and you can solder on top of that with no issues. But just if you have one, fine. If you don't, because it's hard to buy, no problem, you can fly. You probably will not fly in rainy weather, you can just fly in sunny weather with no issues, and you don't need this coating. So next one, different kinds of measurement devices, for example this one. Yeah, so in some cases, imagine you even would like to measure a boat, yeah, so what size of the boat you have, yeah, so it can be very useful here. So that's why I always have it. It can be very useful, so this caliper, and have it not too far from your working space, because from time to time you really need it. What else? Different kind of case. I have many of them. So this one, usually you can buy a set. I'm using probably couple of these tips only in order to attach propellers to motors. You can obviously use less advanced tool and fix your motors, fix propellers on your motors. There are no issues, but I prefer to use this one because if you're assembling many drones, it's just faster. Attach propellers, test something, detach propellers, never test drones in-house. Apply any kind of update software, I don't know, update controller with propellers, always remove propellers. So it's a common situation. Then you attach propellers, after that remove, attach again, etc. So this range can be very helpful. It's called socket range set. Make sure that you have Matek sockets as well, because the most of components that I demonstrated you made in China, all of them, they're using Matek system, and it means that you need Matek sockets. Very important. And even bolts, hard to buy all these bolts. I mentioned that we need M3 10 bolts. You cannot buy them in Home Depot, or if you find some of them, they will be very expensive because they have Matek measurement, and it means that okay, potentially you can try to switch to the current system that you have. For example, in Canada we don't have all this like system based on inches, etc. But your frame even has some embedded nuts, and you are not able to use bolts that you are buying in Home Depot in order to even assemble your frame. Yeah, so that's why, yes, always use, if you are not building your own drone from scratch, including frame from scratch, etc., try to use Matek components. I have these Allen wrenches as well. I have a set, I believe, different kind of wrenches, and some of them are here. Should be more, but I'm probably using them, so they should be in the box. And you can use these Allen wrenches, so you can use these tips for just in order to fix almost everything. Which sizes, nobody knows, because different components requires different sizes. So you always have a very broad range of these tips or these Allen wrenches. That's why I would recommend to buy a set. A set, if in case of socket wrench, probably you just need one tip only, because most of nuts for motors, for propellers are pretty standard. This one, even to assemble a single drone, you need several sizes of them. Yeah, so I always have a box of this stuff, and number of Allen wrenches will grow because some components, like cameras, for example, can contain some, you can see, small wrenches in order to assemble it, because we have really small bolts there. Some of them you will get with, for example, a 3D printer, etc. So I have much more, but it's something that I'm just holding on my table in order to just pick the right one, assemble something, and done. And probably that's all. Let me look at my table once again to see if I can find anything that I did not show you. Probably nothing. But the most important stuff. Okay, you have your drone. You have all needed tools and you assembled your drone thanks to all the tools that I just showed to you. But now you would like to fly. Obviously, in order to fly, you need to set up your drone. In order to set up your drone, you need a computer. Some systems like Betafly you can set up even from a mobile phone device. But it's still like nice to have a computer. I believe it's not a problem. But what is the problem? You need to have some devices in order to manage your drone, in order to fly, and in order to get video from your drone. So what you need to have? Obviously radio controller. Many of them you need to buy a radio controller that will support external modules. In my case I have a controller with Radio Master. It's XT60 Connectors. It's probably the most cheapest controller with a really rich set of features. We have cheaper controllers as well, but this one probably is very flagman, and if you compare to like other controllers, other companies that produce like similar controllers, this one is like pretty cheap compared to others. And it has a socket for external modules. And since we are using Gemini CrossBand receiver in our drones, you need to buy Gemini CrossBand external module for your controller. Even if you have like another one, you can buy this one, and if you have a socket, just connect to your own flight controller this external module that should support ExpressLRS CrossBand. Just make sure that your controller has a socket for external module. This controller you can buy the same. It's from Radio Master. It's a Radio Master external module called Nomad. Nomad from Radio Master. So buy this one. If you have another controller with nano socket, it has nano socket adapter as well. I don't have it, but it's in the kit. So if you buy this external controller, it will work fine. Obviously, once we set up the drone, we'll make a video about how to set up a controller, how to use external adapter and set up all these parameters. Now we don't need it. We just need to remember that we should have a radio controller with a module that supports ExpressLRS. And it should support, obviously, our frequency. In our case, it's dual band antennas, so it's 9, 15 megahertz and 2.4 gigahertz. Make sure that you have needed antenna, so they should match. The second thing, you are going to get video and you need some sort of display or glasses. I have not very expensive thing. I have something called Cobra from SkyZone. This is analog system. Very important that we are not building digital drones. We are building drones that are translating analog video signal, and it allows us to fly with like using long range distances, because in case of digital, first of all, digital cannot fly so far as like analog systems. The second, digital usually they have proprietary components inside, so you don't know how they are working. And compared to analog, like you are using standard format for analog video, there is a disadvantage in analog because you just broadcast your analog signal to everybody. So it's like TV. Everybody who has antenna and can catch the same frequency that you're using in order to broadcast your video can see what is happening in your drone, can just get your signal and see what is going on. That's why in military operations, usually you need to change power for your signal, and especially if you're going to return your drone back. So if you are starting your drone or launching your drone from a spot, you should apply a really small amount of power to your video transmitter to make sure that your enemies cannot catch your video signal. After that, once you fly away from your spot, you can increase power. We will discuss this stuff probably in a separate video or whatever. We have more expensive systems, even with some dioptries and with ability to match. If you like a person that is vision impaired person, you can potentially use their glasses in order to manage your drone and match your settings of the glasses to make sure that they are the same like your standard general glasses in order to see better. But in my case, I have this Cobra Skyzone that we are going to use. But this stuff I'm using usually, then I'm really going to fly. Moreover, if you can assemble drones, and if you expert in even drone programming, it doesn't mean that you will be able to fly. Yeah, some people cannot fly. I'm not flying, for example, very well. I can assemble drones very well. Yeah, so in some cases I'm using, just in order to test a drone, I'm using like a monitor. It's very cheap monitor, the same 5.8 gigahertz. Imagine you are sitting at home, you just would like to see that your camera, you check if your camera is working or not, you just power up this monitor and see. Once you can see an image, everything is fine, and you can just go ahead and finish your drone after that. And final element that we need to have: battery. Battery, in all cases, is going to be, we can use potentially two kinds of batteries. Yeah, we can use lithium polymer battery, Lipo, or we can use lithium-ion batteries. Lithium-ion is something that probably we will need to create ourselves, and lithium-ion batteries, they can potentially grant you longer flight, but they cannot provide much enough current if you're going to like reach the highest speed. So lithium batteries in this case are not the best one. If you would like to reach the highest speed that your motor can do, lithium polymer batteries are the best. This one not the best, of course. There are several parameters. In our case, the most important thing to remember that for these motors, for that flight controller, motor controller that I demonstrate, we will need to have a battery called 6S battery. 6S battery that has 22 point something volts. And more amperes per hour better, obviously, but more amperes per hour, it means that you have bigger battery. Since we are building a drone that potentially can carry, even with battery, 3 kilograms, if you can find a battery that has 6,000 milliamps per hour or even 10,000, fine. They will work. Our drone can carry it with no problem and still have a really good payload. In my case, I'm using not very big battery, with just 4,000 milliamp per hour capacity, but in order to test it in a short range with couple kilometers, it's good enough. It's good enough, I believe. 10 minutes or so our drone can fly with no issues. So it's the latest, finally, component that we need to use for our drone. For batteries, lithium-ion batteries, they are not so explosive, they are not so dangerous like Lipo batteries. Lipo batteries are dangerous. For your safety, never charge your battery in-house. It's better to charge it outside. It's better to make sure that outside temperature is not very high. And it's better to use a special bag to store this battery. Usually you can buy a battery with a bag on Amazon with no issues, but always use the back. And if you can see any kind of damages, or if you start extending in size suddenly, don't use this battery. So because lithium polymer battery are very dangerous. I will probably write a session about safety with drones, and we'll discuss basic exam that you have to pass in Canada in order to operate a drone that is more than, I believe, 400 grams. And our drone is going to be 1 kilo plus 500 probably grams, so more than 400 grams. Very important to make sure that you are running your drone in very safe environment, because imagine if a drone that has a weight 1.5 kilos will hit a head, it potentially can kill a person even if it does not have any additional components on it. So it's very dangerous toy, and make sure that you are in safe environment prior to start any drone, and never test your drone, never set up your drone with propellers. It's like basic thing that I would like to provide in advance, but we'll repeat it again and again. Yeah. So that's all what we need in order to assemble our drone, tools and components to operate finally our drone once we finish with assembly. And I believe that's all. I tried to show everything. I hope I did not forget anything, and in next video we will finally start assembling something, and we will assemble our frame.
And I'm back again. In fact, once I finish encoding the video, I found that I missed some components. I have my internal list, probably will share it a little bit later, but I forgot about at least 4 different things. First of them is going to be a smoke stopper. It's a thing that allows you to connect battery from one side and connect your drone from another side. And potentially it should limit current to a drone. And if you assembled something wrong, it potentially should stop providing any current to your drone, or at least signal you that something is going bad. So there is some overloads or anything like this, potential shortcuts. It has just 2 or 1 red, but at least it can be green or it can be red. And by default, if everything is okay, your red should be green, and it means that smoke stopper did not find any issue. At least your drone potentially does not have shortcuts. It doesn't mean that everything will be fine after that. And you can remove smoke stopper after that. And after that, you can connect your battery directly to your drone and start setup process and test your drone, etc. If it shows red, signal, and there is a beeper, probably it will beep, who knows. It means that something really wrong with your drone. You assembled something really wrong, and disconnect your battery right away and check everything. Nobody knows if it things really works. At least I did not see it in action, but I believe that it should. That's why I'm using it every time. Then I connect my drone to the battery for the first time prior to test if everything is okay. Potentially it can prevent damages for some of your components, and potentially you won't be able to see smoke and fire, etc. once you connect your drone to a battery. So use this one. Lots of different versions of this stuff. I bought it on Amazon, I believe. The second thing, different kinds of tweezers in order to work with cables and probably remove connectors, small cables from connectors, the sockets, etc. Don't buy plastic. on Amazon you can find tweezers and reverse tweezers exactly for soldering. So buy them. Usually you can buy 5 or 10 of them in a kit and not very expensive. And next one, yes, you have a battery in order to operate your drone, but you need a charger for your battery as well. And buy a charger that can charge usually a battery starting from 2S configuration up to 6 and probably 8S configuration. And once I looked at the charger, I started to remember that, oh, I forgot one more thing. I demonstrated glasses and I demonstrated radio controller, and both of these devices need batteries as well, and very different. I believe radio can use 2S battery, and there is a battery that you have to buy separately. You can buy it on a Radio Master site, or I believe I bought one on Amazon, but it's one more battery. It's small and it just bother your radio control. And the same for glasses. Glasses, they sell them with no batteries as well, and there is, I believe, lithium-ion batteries that you have to buy on Amazon as well, and it was the most complex thing because they have like special big rechargeable batteries that I found really hard to find. Moreover, they have 2 different form factors. So I don't want to show them right now because it depends on what you're going to buy in order to manage your drone. Probably you have to look at specification and see what kind of batteries you need to buy in order to power your devices. And now I believe that it's definitely all what you need. Thank you.